Okay, so today we're going to talk about exponents. I'm going to take some notes in our Math Interactive notebook. So what we want to write down is this one right here. Number one, what are exponents? And we're going to take those notes on page 7. Now in math, every computation has what's known as like an inverse or an opposite to it. So we know that adding, its opposite computation is subtraction. Another way to look at that is positive numbers have an opposite of negative. Then we have multiplication, its opposite is division. Another way to look at that is the opposite of multiplication is its reciprocal, or multiplying by its reciprocal, what Miss Egan likes to call the refliprical. And now we're going to talk about exponents, which is, technically another computation. And all of the computations are related. So, for example, repeated addition can be represented by just doing multiplication. Repeated subtraction is represented by division. And now we have exponents, which is going to represent repeated multiplication. Okay, so we're going to go ahead to page 7. We can start taking our notes. So at the top, what are exponents? So exponents, sometimes called powers, represent a mathematical computation or repeated multiplication. And of course, you need to know what it is that you're multiplying, right? Like that's the key. So when we say repeated multiplication, what we really mean is that an exponent tells us how many times to multiply a base by itself. Okay. So when we look at an exponent, we have what's known as the base and the exponent or power. And every term, and actually every part of a term, has its own exponent or power. So what we need to realize is that when an exponent is not provided, it is assumed to be 1. And that might sound weird that it's 1, but here's the thing we talked about the other day, is that when we talk about additive inverses, our goal is to get something to 0. Because when you add or subtract 0, it doesn't affect the value of your situation. Well, with multiplication, if we multiply by 0, that would affect the situation or the expression. So here, our goal is to multiply by 1, because when you multiply or divide something by 1, it doesn't affect it, right? So that's why this isn't 0, it's 1. So what does that mean? It means if I have the term 2x, if I wrote that with exponents, it would be 2 to the first and x to the first. Okay, so that leads us to our next thing is that we need to be able to read and write exponents. So we're going to just make a little chart here. So exponent or power. The words to go along with that. And the factors. Okay. Now, when we're representing or doing, exponents, essentially, it's another way to represent a standard number, right? Standard numbers 1, 2, 3, 4. So when we have 3 to the first, the words are 3 to the first power. Okay, and the factor is just 1, 3. If we go 3 to the second power, right? 3 to the second power, or 3 squared. And our factors would be 3 times 3. The reason why we call it 3 squared is because how do you find the area of a square? It's one side times the other side, and they're both the same value if they're a square. Then we move on and we have 3 to the third power, or we call it 3 cubed, because a cubed is a three-dimensional representation of a square, or essentially it represents value. 3 to the third, and that would be 3 times 3 times 3. So the second power and the third power kind of have special words. And then we move to the fourth power, and everything beyond the fourth power is just 3 to the fourth power. And we abbreviate that as 3 to the fourth. And as I said, it just goes on. We'd have 3 to the fifth, 3 to the sixth, 3 to the seventh, etc. Okay. Now, things we need to know. Over here, I haven't been able to see for a little bit, so I'm going to push that up. Over here, we call this exponential form. Over here, we call this expanded form. And if we added another column and actually computed the math, we would have 3. 3 times 3 is 9. We already know 3 times 3 is 9, and 9 times 3 is 27. So we know 3 times 3 times 3 was equal to 27, and 27 to the third power, or 27 times 3. So 2 times 3 is 6, so 20 times 3 is 60, and 7 times 3 is 21, so this would be 81. These are just still our standard, sometimes called fixed numbers or terms. And that's how we represent exponents. But unbeknownst to you, everything you've been seeing has an exponent. It's just probably 1. Now we're moving into the point that we're going to do more than 1. When we say it's another way to represent a number, think about what we know. We now know that 3 to the second power is the same thing as 9. 3 to the first power is the same thing as 3. 3 to the third power is the same thing as 27. Okay, so different ways to represent the same value, while in this case it's also representing computation, and that computation is repeated multiplication of the base. And the base is one way to look at that is the big number, and the exponent is a small number. The exponent tells the base what to do. And that is our notes for today about what are exponents.